talking about, how physics has the ability of describing our universe, I think a little differently, or at least this is my opinion. So in the Does Math Even Exist video, right, we were saying that math at the end of the day is a very conceptual topic. It's very abstract, right? Like it doesn't really represent any physical thing. However, physics, on the other hand, right, like that directly describes certain physical, phenomenon. For example, F equals ma, right? The most of a very easy example, or your force of gravity equation, your mass over r squared. So all what that is explaining is what we physically observe, right? Like if you push something with a certain force, it accelerates. You can observe that using these physical equations. So that's why I think physics, a little differently from math, is not as conceptual, but describes the universe in a different way and a realistic way. What do you think?
As I said earlier,
Yeah.
like in our previous episodes, like physics is using math to its advantage, obviously, because
True,
it's
of
much
course.
easier to write things down mathematically versus in English trying to describe relationships. Describing a linear relationship is a lot easier when you just use symbols instead of trying to explain. The thing about physics itself is that it's built around the ability to write things down. The fact that I can look out into space, see something going on, and then I write it down. Realistically, it doesn't matter that I can physically write down the relationship. It's the idea that I can take an observation and form that relationship in essence, right? So that idea, that relationship exists in my head. And so my take on it is that physics is not real. Answering the question of the episode, right?
Yeah.
I don't think physics is real. I think physics is just it's a body of knowledge, right? It's just this well, it's an infinite. It's like the real number line, right? There is no bound to it, but we only hold as much as we know, right?
Okay.
When we keep expanding our knowledge, but there is, or in my opinion, there is no end in sight, right? There is no real, well, that is a whole topic on its own that we did talk about last time.
But see, if you think about it, like physics, like even though is, world of knowledge, I don't think you can say, like, for example, then you can use that same argument for any of the sciences, like even chemistry or biology. Like they don't necessarily have to, if we're just talking about chemistry, it represents,
that's true.
different realms of knowledge, right? And they can be applied in different ways. Obviously, we're not even close to knowing how much chemistry there is in the world, right? We're not even close. Same way with physics. So at the end of the day, if you just talk about them like just as a subject, I think, yes, I can definitely see your point. Like none of them truly exist. But it's when we, apply it to real life phenomena, to real life observations, as you said, like we observe something and write it down. Like that equation, what we call physics, represents that real life phenomenon. So would you not deem it to be real of some way?
Here's why I don't
sort.
think so.
Okay.
Because let's say we use Newton's equation to find a force acting on an object.
Okay.
And we find that number, okay? But do you think that number, like the result that you find, it represents a real thing? Fair enough.
Yeah.
But in reality, it is just an approximation that but well, hear me out,
Yeah, I'm listening.
It's just an approximation of a fairly good one. Right? I'm not going to say it's a great approximation because there are many situations where it does break down. But, let's say we're under mild conditions and we find a result for a force that's acting on an object. That result depends on our observation, right? It depends on what we observe the acceleration to be, what we observe the mass of the object to be. But if you do believe in like a deterministic universe, then you do believe that there is, in essence, right, in its purest form, there is an exact number that represents the force being acted upon the object.
That is true.
Is that right?
That
you
is
think
true.
that like it's embedded in the code of our universe
of course,
somewhere.
Of course.
That there's a perfect number that exactly
exists.
describes the force being applied.
Okay.
The reason why I don't think that physics is real is because we will never be able to get to that number.
True. That is a fact.
Using physics.
That is
Physics is just, you know, I think it's like there's a muddy lake, let's say, and you're trying to find the gold, the gem that is at the bottom of the lake, right?
Okay.
You know, physics is kind of like these binoculars, right? You can kind of zoom in to the mud and the cloud of dirt, and you can see like a sparkle, but you'll never be able to just see exactly where that gem is.
Yeah. True.
To actually figure that out, you need to plunge into the lake and actually grab it, which is, you know, only the hand of God can perform that action in terms of physics.
I think this is that is actually a fantastic point that you brought up, because I was actually because when you sort of were talking about that, the first thing I thought of was uncertainty, right? And in almost any kind of lab class that you do in university, or any physics lab class, or any lab class for that matter, you will definitely encounter uncertainty propagation. Or what that means is calculating the error in your observations or in your measurements. So you will find out that, I mean, believe me when I say this, obviously, like, I just finished the semester, so I just finished my lab class, and there were so many reports where I forgot to put the uncertainty in like these small variables that I thought wouldn't matter. But basically the moral of, you know, getting all those marks deducted from my reports was every value, every observation has some level of uncertainty. So what Parker said there was actually a very good point brought up, because at the end of the day, every force or any equation that we calculate will have some uncertainty relating to it. So as you said, we won't get that exact force. We never will, because that force will have some uncertainty relating to it. So we're never going to get the exact number. And that's just unfortunately a consequence of physics, and or I think just measurements, right? Like everything has its own embedded error.